We're still in the middle of our Reiki touch therapy problem, and now we actually want to conduct the test of whether there was a mean or whether there has been a mean reduction in pain level after the Reiki therapy using a 0.05 level significance and the p-value method. All right, now remember we already established what the hypotheses would be. It's that the mean difference is equal to 0, the mean difference is less than 0. Then when they say level of significance, notice I highlighted it in blue, that's because that's your alpha level, right? Level of significance is alpha. All right, now step 3 means that we're going to have to find our test statistic. So let me grab that test so you can see it. Oh, there it is. So we need d bar O divided by SD over the square root of n. Okay, so to do that, I'm going to need my d bar and my SD, but we already found those a couple pages ago. D bar was negative 1.923. S standard deviation with respect to the differences is 1.605. All right, so I'll use those values and fill them in here. So D bar is negative 1.923, SD is 1.605, square root of 13. And as much as I'd love to tell you you're going to do a fabulous job of doing this all the time, that's not always the case. So let me just show you here. I gotta check here. Yeah. So stat, calculate, tests, number 2, t-test. We're going to choose it from data, and our data is in L3, and our mean difference is 0, and we wanted a less than test. Go down to calculate and press enter. And there we have it, negative 4.319. So remember, it doesn't actually matter that if you do this part in your calculator by hand or not. So considering how tricky this can be to enter into the calculator, I would say it's much smarter to use the t-test. And remember that I told you right on the inferential statistics sheet right here, I tell you what test to use. So when I do that, I'm giving you what you need for steps 3. I'll give you the result for that, and step 4. Now you still have to show the formula and all of that. That's true. However, despite that, that t-test output gives you X bar, that's your D bar. S right there is your SD, and there's your N. It's giving you everything you need. So if you run the t-test, it gives you all the stuff you need for step 3 and some of what you need for step 4, namely the p-value right there for p. Speaking of which, we are doing this with the p-value. So that'll be step 4. We're going to have to draw a normal curve, well, a t-curve actually, a t-curve, and we're going to have it be left-tailed drawings. So if you look at your drawings, you're going to be drawing the left-tailed one over here. And you're going to use t0, which is that value the calculator found, and the p-value. That's not like the critical value method. The critical value method means you're going to have to go to the table or inverse t and find t alpha. But we're not dealing with that. We're doing the p-value method. Okay, so the p-value I know is 4.4 e negative 4. I don't know if you caught that, but there is scientific notation on that. All right, so remember that a p-value is a probability. It's an area under that probability curve, the t-curve. Well, no area under a probability distribution could ever be bigger than 1. So if you look at this and it says 4.98 and you write that, you will lose credit in a big old way because you should know that no p-value is ever bigger than 1. It's actually e negative 4, exponentiation negative 4, which means it's 0.0004986. So I wrote 0.00049, which is 0.005. And this means we are very much going to reject the null hypothesis because you reject the null hypothesis if your p-value is less than alpha. And if you know nothing else from this course, you know that you need a low p-value, and the lower the better, right? The lowest p-value is the best p-value. Okay, and this is low, and therefore we are going to reject the null hypothesis. That means our result is statistically significant. All right, so then step 6, there is enough evidence to support the claim that the average pain level was lower after the Reiki touch therapy. All right, good there. Now we have to do the classical method. So we're not redoing the whole test. I mean, on the exam, you're either going to do one method usually or the other. So you have to prepare yourself for doing either method. And so now we're going to redo steps 4 and 5 because the other 4 steps don't change. Step 6 is the same no matter what you do. Step 1, 2, and 3, steps 1, 2, and 3 are the same no matter what you do. Step 4 and 5 are where the differences are. So let me go back and look at those differences real quick. Over here on the p-value method, you use t-zeros and you label your p-values. Be very careful with the two-tailed p-value, by the way. It's the p-value that the calculator gives you is actually already both tails put together. So make sure you write it at the top and put an arrow that goes to both sides. Now, the critical value method, however, is finding your threshold for distance. So you're saying, okay, how many standard deviations away do I need to be unusual? That's a critical value. So if you're doing the left-tailed test right here, that's negative t alpha. Okay, so we need to draw that and we need to find it. Well, it's going to get drawn very similar to the other graph we already have, except we're going to have to find that negative t alpha business. Now, I said right in there in the instructions, it's with degrees of freedom n minus 1, degrees of freedom n minus 1, and either inverse t or the t table. So your alpha is 0.05. So in your degrees of freedom is right here. It's 13 minus 1, which is 12. So I grab the calculator and I go to inverse t, which is number 4 right here, 0.0512. There we go. Negative 1.782. And it's negative, which makes sense because this is a left-tailed test. Negative 1.782 is much closer to the center than negative 4.309, right? And that means that we are going to reject the null hypothesis, because in a left-tailed test, you reject the null hypothesis if your t0 is less than your negative t alpha. So our test statistic t0 is very much less than your negative t alpha, which is negative 1.782. So negative 4 is less than negative 1.7, and therefore we reject the null hypothesis. And before I leave this page behind, I just want to make a couple comments, which is one, when you're running a hypothesis test in this course, with just a couple exceptions, you have to do all of this. There is no symbol, no graph, nothing in here that is not necessary, with the exception of maybe labeling this p-value down here, right? You have to label it on the graph, but you maybe didn't have to say how you rounded it. That's it. Everything else, labeling your steps, saying your p-values, saying this is t0. It's not good enough to just write negative 4.3. You have to actually state it's t0, state your p-value, etc. All of this is required to receive full credit, all of it, including substitutions in the formulas and everything. And also, just before I go, I want you to realize that this is extremely similar to what we learned in chapter 10, right? Very, very little difference here. The only thing that's different is how we set up these hypotheses, because we're talking about a difference, so 0 is always your null. And then instead of using x bar and s, we're using d bar and sd. But other than that, it works almost exactly the same as chapter 10. Just steps 1 and 3 are a tiny bit different, and that's it. Everything else is the same, including the conditions you need to meet. That won't be the case in the next section in 11.3, but we'll see that in another video later. All right, we're all done with this, and we now know how to run hypothesis tests by hand, either using the p-value or classical method.